and I come from Natural Resources Institute. And I tell you a case of circular economy. It's called Palopuro Agroecolocial Symbiosis. I don't know if you have heard that kind of word. It's a little bit complicated, but it describes quite well this case. It means that we have taken industrial ecology there and also biological symbiosis and put them together so that they work in food production. Let's have a look for a while in this picture. So this is a picture of this symbiosis. Palopuro is the name of the village. It's in South Finland, and those farms and everything is there. They almost all they already exist. At the center there is a farm. Maybe I found somewhere this pointer. Farm is here in the center. It's organic farm, and it's quite big in Finnish scale. It has about 360 hectares field, and it's a cereal farm. It doesn't have any animals, but they have also a kind of restaurant here and a little farm store, and they have farmers markets. So there's a natural link to the consumers, the food. And then there are other enterprises. This hen house, it's about 1.5 kilometers away from this farm center, and vegetable farm, a small one. And biogas plant is, at the moment, they are building it, but it doesn't yet exist. Bakery and milk. A bakery has decided to move in here, but it's not yet there. But the idea is here that the nutrients, they go from biogas plant to fields, and the grass is the main biomass to go to the biogas plant. And then the manure from hen house goes to the biogas plant, and also some horse manure outside of the symbiosis. And the nutrients, they go around here so that the farm is able to sell the grain to the mill and bakery, so they get better price for it, and the bakery gets it cheaper than buying outside. And the energy, it has planned that some of the energy goes to the dryer. Maybe you know that in Finland we have to dry the crops and it takes a lot of energy, and some of it goes to the bakery, and they need especially gas, like the heat of gas. But most of the energy, it's planned that it will be fuel for the transportation, also for the farm, but most are sold outside. Okay, and here is the farm and the bakery and the Ministry of Environment who has founded this project. And this is the farm that is actually the center of the thing, because the couple, they were very eager to develop this kind of symbiosis. Yeah, of course I thought. Then there are 2 minutes lasting video, but I can find it here. sound so that everybody can hear.
Palopuro Symbiosis, a sustainable model for food and energy production. Humankind's need for nutrition and energy is constantly increasing. As such, food production must respond to global challenges such as climate change and population growth. In short, food should be produced in an increasingly environmentally friendly and affordable way. At Palopuro in Hyvinkää, Finland, agricultural producers are responding to the challenge with a new kind of cooperative model. The community's operations are based on an agroecological symbiosis that is self-sufficient in both nutrition and energy. Their aim is to produce food and energy in an ecological and economical way by utilizing and recycling local resources. This symbiosis is embodied by the Knitila farm, a henhouse, and a vegetable farm. Consumers can purchase delicious organic food directly from the farm premises, and the Knitila farm's country markets and other events are now also a familiar local sight. In the future, green manuring lays will be processed along with manure to form biogas in the new Symbiosis's innovative dry anaerobic digestion facility. The gas will then be used to dry grain, drive tractors, and power the organic bakery planned for the farm. There will also be enough gas left over to be sold as fuel. The residue left over from biogas production is excellent fertilizer. The symbiotic process recycles nutrients, promotes crop growth, and reduces stress on waterways. Grassland farming and organic manuring bind carbon dioxide to the soil, while biogas production replaces energy derived from fossil fuels. The Palopuro Symbiosis model is an excellent example of how food production can be ecological, economically profitable, and an experience in itself. The Palopuro production model can also be applied to other producer communities, helping them respond to global challenges with local solutions.
Okay, let me see. I think you get some idea of the whole system from this video. Okay, but we will continue. Yes. Okay, and the biogas plant is an important part of this system. And as I said, it's at the moment they are building it. It was a big thing for this symbiosis that the regional energy company called Hivos Energia wanted to be in this biogas company, because it would have been quite impossible for the single farm to do it. But the energy company, they have been looking for quite a long time this kind of case where they can be with. And but they have the biggest, they own the biggest part of the company, biogas company. And then the local operators, the farm and all the others, they are also there. And the biggest part of the feed to the biogas plant, they are green manure lays, because in organic farm there's about 1/3 of the fields they grow green manure lays. So in this case it's 100 or a little more than 100 hectares. The horse manure, it's coming outside and also brings some money and nutrients to the symbiosis. Chicken manure, and that all it comes from the close by Henry. And this quite new system because all the materials, they are dry. There's no slurry or no liquid feeds. And the next idea is to replicate this system to a larger area. And actually at the moment there is another project going on. It's led by Helsinki University, and the money also comes from Ministry of Environment, from RAKI program. And the idea in this project is to find more places for this kind of symbiosis. Of course, they are not exactly this kind. There are many other possibilities like food waste and to handle food waste in biogas plants and so on. And the farms are different, but still the energy company, they want to have this kind of cases around its area. And here is a picture about the biogas reactors. We have a specialist here, also Juha Lostarinen, and we go in the afternoon. We go to see this place in Laukaa, Metene. But the idea is that there are 2 silos, 800 cubic meters each, and they are batch reactors, so that both of them, they are built 3 to 4 times during the year. And here is the gas storage, and then it needs a liquid tank, because the liquid is going around this. It gives the water here so that it goes the liquid around surrounding. And this is to make the fuel. Two days ago it looked like this. So they have started it, and the work is in schedule. So this is the place where the 2 batch reactors, they are coming. There was pretty much rock in this place, so it needed some extra work in the beginning, but the place should be good. And the biogas production is quite in the center in here with the nutrient recycling. And the 2 important things are that it's better fertilizer when the biomass goes through the biogas plant, and if it's only green manure layers which are put to the same, cut and put to the same place where the grass is, there is some of the nutrients, they go so that they are not usable for the plants, and also it's not possible to move them to some other place. But now, when the grass is taken to the biogas plant, it can be spread where it's needed. And also for the house manure, it's a better use than just composting. It reduces nutrient leaching, and also the grass that grows near there's little river can be taken there. And of course, the energy is important thing, but somehow I wanted to take first the nutrient recycling here. Here is a picture of energy flows, nitrogen flows. We don't have time to see the numbers, and you don't have to look at them, but the size of the arrow shows how much nitrogen is going and where it's going. So this is nitrogen fixing that legumes do. some deposition also from air, something from a horse manure, chicken feed, because the hennery is here now inside the symbiosis. So something is coming from chicken feed outside and also the poultry themselves. And the biggest arrow here are nitrogen losses, because it always happens mostly from land and also from biogas plant. Then some of the nitrogen goes away in crops, through bakery in bread, and through hennery in eggs and hens. And here also some losses. But it seems to be quite in a balance, at least here when it's calculated. And here is phosphorus, the same kind of picture of phosphorus. Here the chicken feed is quite a big amount of phosphorus that comes in, and also horse manure. And the biggest is going out in crop sales. But this is not so complicated than the nitrogen, of course, because the losses are not so big here. It doesn't go to the air. And so it's going out in eggs and hens. And here are energy flows. Here you can see that the biggest energy potential is here in the field biomass, in the grass, and something in the horse, and maybe this changes a little bit because there are now more hens, but still the difference is clear. Then they go to the biogas plant, and this is the amount of energy that goes to drying the crop in the farm. And as much goes here to the bakery, but this is the most, the biggest amount of energy that goes to the biomethane refining, and this goes for the sale. And to complete this, some electric is of course coming in to the biomethane refining and to the biogas plant, and of course also to the farm, but you can see it here. In this case, it was calculated that we didn't want to have a CHP to make electricity, because in Finland electricity is so cheap that it's no use to produce it to the grid. So it's only that the farm needs itself. They decided like this. Okay. And I already told about the consumers, so it's quite important to have them here. And the farm has been an energy consumer, but now it can be a producer. And also the farms are usually the producing raw material, but now this system turns it so that the farm can produce food, or the whole system can produce food and not only raw material. And the consumer cooperation. But this model is quite new in Finland, and it's very interesting to see how it works. But it has also impacts of the social life of the area and the local economies. It has been shown that the consumers are very eager to come to the farm and see the system and visit it, and it's one part of this thing. And there are, at the moment, there are coming 2 doctoral theses in this case.